Okay, hi guys. So in the previous lecture, we were seeing the types of Lewis acid. So now let's start on a new topic on the Lewis acid, which is the comparison of Lewis acid character. Okay. So suppose we have beryllium, calcium, barium, sodium, potassium, cesium. So what would be the Lewis acid character? So this is of this order. And why is this the case? Because Lewis acid character is directly proportional to the charge density of cation. Lewis acid character is directly proportional to charge density of cation. And charge density of cation means it is the ratio of charge to size. Okay, so Lewis acid character is directly proportional to the charge density of cation. It never depends on the number of vacant orbitals present on cation. Please note that it never depends on the number of vacant orbitals present on cation. Okay, next we have to compare between SiCl4, AlCl3, BCl3 and PCl5. So the order would be PCl5, then SiCl4, then BCl3, then AlCl3. Again, we are comparing all the molecules based on the central atom. More the charge on the central atom, more would be the Lewis acid character, and lesser the size. If they have the same charge, more would be the Lewis acid character. Next, let us see the comparison between SiCl4, CCl4, AlCl3 and PCl3. We have to compare again Lewis acid character. So in this, it would be, the order would be first SiCl4. It is having the maximum charge and again C is also having +4 charge and Si is also having +4 charge. The reason why CCl4 will not act as a Lewis acid, why? Because carbon does not have any vacant orbital. So where will it accept electron into? Si does have vacant d orbital plus 4 and it is also having +4 charge, which is highest among these two. The remaining these two are the last ones. Next, the order would be BCl3, then AlCl3. Both Al and Bl, both Bl and rather Al and B, beg your pardon, both aluminum and boron actually have vacant orbitals, vacant p orbitals to accept electron into, and boron has a smaller size than Al, so it would be a better Lewis acid. So CCl4 never attach electron as it is not having any vacant orbital. Okay. So one more note here, that CCl4 and CH4 never act as a Lewis acid. Never act as a Lewis acid. Okay, as they have no vacant orbital. Okay, next let us see the comparison of Lewis acid character on if we have SiI4, SiCl4, SiBr4 and SiF4, all with respect to Si, all have +4 charge, but now Lewis acid character would depend on the electronegativity of the atom which is attached to silicon atom. Why? Because more the electronegativity of the atom of attached on the silicon atom, more would be the partial positive charge developing on the silicon atom, and more would be its Lewis acidic character. Hence this would be the order: SiF4, then SiCl4, just arranging it in the decreasing order of the electronegativity of the halogens. So as positive charge on central atom increases, Lewis acid character also increases. Okay, now one more note here before we end. That SF6 does not act as Lewis acid due to steric crowding around the central sulfur atom. However, sulfur is having weakened orbital, but due to steric crowding it does not show Lewis acid character. So SF6 does not act as a Lewis acid due to steric crowding around sulfur atom. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing the comparison of Lewis basic character. So till then, good luck and goodbye.